Imagine reaching Mars in half the time it takes today, thanks to a rocket powered not by fuel, but by a nuclear reactor. Space exploration has always been limited by one thing: speed. Chemical rockets can get us to Mars, but the journey takes around 7 to 9 months one way. That's nearly 2 years of round-trip travel, plus months of waiting on the surface. For astronauts, that means more exposure to dangerous cosmic radiation, more life support supplies, and more risk. But what if we could cut that time almost in half? That's exactly what scientists are working on with nuclear-powered rockets. So how does this work? Traditional rockets burn chemical propellants, basically giant explosions controlled by physics. Nuclear propulsion takes a very different approach. Inside the engine sits a compact nuclear reactor. Instead of using combustion, it uses nuclear fission to generate heat. That heat supercharges a propellant, often liquid hydrogen, forcing it out of the nozzle at incredible speed, creating thrust. The result? A much higher specific impulse. That's rocket science lingo for efficiency. Simply put, nuclear rockets can squeeze far more performance out of less propellant, which means faster trips through space. But here's where it gets really exciting. A team of researchers at Ohio State University has proposed a brand new concept called the centrifugal nuclear thermal rocket, or CNTR. Instead of using solid uranium fuel rods, this design spins molten uranium in a rotating cylinder, like a nuclear whirlpool. That spinning motion stabilizes the liquid and lets the engine run at far higher temperatures than solid designs allow. Why does that matter? Higher temperatures mean faster exhaust, more efficiency, and shorter travel times. The CNTR could potentially deliver a specific impulse of around 1,800 seconds, about 4 times better than chemical rockets. Let's put that into perspective. With chemical rockets, a round trip to Mars can take nearly 3 years. Using a CNTR design, scientists estimate we could cut that down to about 420 days, a year and 2 months. That's not just faster, it's safer. Less time in deep space means astronauts are exposed to less radiation, less microgravity, and less risk of mission failure. Plus, shorter trips mean we could launch more often, carry more payload, and even consider exploring farther into the solar system. Of course, this isn't ready yet. Handling molten uranium in space at thousands of degrees is an enormous engineering challenge. The materials need to survive extreme heat, radiation, and constant stress. Then there's the safety factor. Launching a rocket with nuclear material on board isn't something governments take lightly. Strict regulations, environmental safeguards, and international treaties all come into play. Right now, the CNTR exists only on paper, though scientists believe we could have a working design ready for testing in about 5 years. Actual human missions with these rockets? That could still be decades away. Still, the idea is no longer science fiction. If nuclear-powered rockets succeed, they could transform space travel, cutting mission times, opening up the solar system, and maybe even making crewed journeys to Jupiter's moons possible one day. So the big question isn't if astronauts will ride nuclear rockets to Mars. It's when. What do you think? Should humanity take the risk of nuclear propulsion to make space travel faster? Or should we stick with safer, slower rockets?